Greetings to all viewers. This is Professor Ankit Singh. We'll now move to the next topic, that is Benkelman beam deflection studies. Okay. So Benkelman beam is an instrument which is used in order to structurally evaluate the pavement and also for designing the overlay. Okay. So Benkelman beam can be used for evaluation of structural capacity of the existing pavement and also for estimation and design of overlay or for strengthening the weak pavement. Now, why do we need this evaluation? Why do we need to conduct this? Pavements deteriorate functionally and structurally with time due to traffic loading and the different climatic conditions. Okay, so pavements tend to lose their efficiency both functionally and structurally. Okay, so structurally they are not able to carry the load and loose form, and also functionally they do not provide the efficiency that they are supposed to provide, and they lose the comfort providing ability. Okay, so this tends to happen with time and with difference in climatic conditions. It is necessary to evaluate the condition of the existing pavement in terms of functionality and structurality. Okay, so the pavement should be good both functionally and structurally. This is why we need to perform this evaluation. Now, what is an overlay? Pavement do not have adequate structural strength to carry out the projected future traffic will have to be reinforced by providing additional pavement layer. Okay, so on top of the existing pavement layer, if we provide a additional layer, okay, in order to increase the load carrying capacity of the pavement, that layer is known as the overlay. Okay, next is scope. So performance of flexible pavement. It is dependent on the elastic deflection of pavement under wheel load. Okay, if the elastic deflection is good, then the pavement is good. Okay, if it is weak, if the flexible pavement does not come back to its original shape or original form, okay, to the minimum degree required, then we can say that the pavement is losing its efficiency. Now, the elastic deflection of pavement will depend on subgrade soil, its type and the moisture content, compaction, thickness, quality of the pavement course and drainage conditions. Now these BBD studies, their test procedure covers the determination of rebound deflection of pavement under a standard wheel load and tire pressure. So in BBD studies or Benkelman beam deflection studies, what we are trying to do is we are trying to measure what is the rebound deflection of the pavement. Okay, once you apply a load, then you take out that load, then what is the rebound deflection, how much is the deflection, that is what we are trying to find out under standard wheel load and tire pressure. Okay, so rebound deflection, deflected pavement structure bounces back to the original shape. Okay, once you apply the load, there is some deflection, then again if it comes back to its original position when load is removed, then the pavement is efficient. Okay, under normal conditions the flexible pavement should show this character, but if it does not return back to its original position and there is some permanent deflection, then the pavement is under fault and we need to apply some corrective measures, which could be design of overlay or even reconstruction at times. So what is the equipment that is used? The equipment used is, firstly we have the Benkelman beam. Okay, it is a slender beam. Here you can see in the picture you have this slender beam with its dimensions as shown here. Consists of a slender beam of length 3.66 meters from here to here. Okay, so 2.44 plus 1.22, this is the length of the beam. Distance from pivot to the dial gauge, okay, is 1.22 meters, this here. So using the dial gauge, what we do is we measure the deflection. Then distance from pivot to front leg is 25 centimeters. Then distance from pivot to the rear leg is 1.66 meters. Okay. So this is the front leg, can say, and this is the rear leg. Okay, sorry, this is the front leg, and here you have the rear leg. So from the pivot, the distance is, for front leg it is 25 centimeters, and for rear leg it is 1.66 meters. Now the next requirement is of a loaded truck. Okay, so the weight of the truck should be 12 tons, rear axle load, which is a standard 8170 kgs, and dual tire assembly on each side. Okay, spacing between the tires should be 30 to 40 mm, and inflation temperature should be 5.6 kg per square centimeters. Then we need a dial gauge. Okay, then also a temperature or even a pressure measuring gauge, okay, to measure the pressure of the tires. Then thermometer to measure temperature of the road surface. Then a measuring tape to measure the distances. So deflection measurement, the point selection, a minimum of 1 kilometer road stretch is to be considered as a study area. Okay, and within this 1 kilometer road stretch, minimum 10 points at 50 meters interval should be taken. Okay, these are minimum points you need to take. You can take more than this, but you should not take less than this. Then we come to the procedure. Okay, so basically what we need to do is we have 3 points. Okay, for the measurement of one deflection. Okay, what we need to do is, if the truck is placed at A, we will measure the deflection once, then we'll move it 2.7 meters, then again we'll measure deflection 2, then we'll move to 9 meters, and then we'll measure deflection 3. Okay, the first deflection measured is D naught, and second is D intermediate, and third is D final. Okay, we'll see that in the procedure part now. Okay, so the Benkelman beam, okay, the head or the pivot is being placed in between the dual wheel assembly. Okay, the probe, okay, the probe is being placed in between the tires. The probe end, which is the this end, okay, the toe of the probe, this end is being placed at the center of the dual wheel assembly. Okay, select the points and mark the points. This you need to do it first. Then the dual wheel of the truck is centered above the mark. The probe of the Benkelman beam is placed between the dual tires at the marked position. The probe is placed here. Now the dial gauge is set to 1 centimeters. We set it to some initial reading. Okay, the initial reading D naught is recorded when the rate of deformation is less than or equal to 0.025 mm per minute. Okay, so the first reading is then taken. Then you need to move the truck. Okay, truck is slowly driven at a speed of 8 to 10 meter per second approximately, at a distance of 2.7 meters, and then it is stopped. Okay, so first it was at a 0 chainage, then we need to move it to 2.7 meters forward, then at the same spot we need to take the other reading, okay, di. Now you need to make a note that we are not going to move the Benkelman beam. The Benkelman beam is stationary, we place it here itself. Only the truck is moved. The truck is first at a point 0 over here, then it is moved forward to a 2.7 meters. Okay, and then again the second reading is taken, that is intermediate reading di. Then truck is driven forward to another 9 meters. okay, and then at the same point again final reading df is recorded. Okay, so you have, for you need to consider 3 d naught, di and df, okay, to find the deflection at a single point. Okay, there are some formulas that we'll use. Okay, I'll tell you about those. Then again, pavement temperature is recorded at least once in each hour. Okay, we need to keep a record of the pavement temperature. Tire pressure is checked at 2-3 hours interval during the day. Now, what is the calculation part? How do you find out the deflection? So, we have d naught, di and df. We need to find out d naught minus di and d naught minus df. Now, how do we find out the true rebound deflection? If the differential reading, that is di minus df, is less than or equal to 0.025 mm, then true rebound deflection is given as d equal to 0.02 into d naught minus df. The answer you will get, the deflection you will get in millimeters. Now, if differential reading di minus df is greater than 0.025 mm, then we need to use this formula, capital D equal to 0.002 d naught minus df plus 0.0582 di minus df in mm. Okay, this is how you find out the true rebound deflection. The pavement rebound deflection at a standard temperature of 20 degrees centigrade shall be calculated. Now, effect of temperature. What is the effect of temperature during this test? The standard temperature is considered, the pavement standard temperature is considered to be 35 degrees centigrade. Now, correction is applied when minimum thickness of the pavement is 40 mm. Okay, if it is lesser than 40 mm, then we need not apply any temperature correction. Okay, so no correction is applied for thin bituminous surfacing, severe cracking in the pavement, bituminous layer is stripped, cold and high altitude regions where daily temperature is less than 20 degrees centigrade. In these 4 cases, we need not apply any corrections. Okay, so correction will be positive when temperature below standard temperature. So if the temperature is below 35 degrees centigrade, this is, we are talking about the temperature of the pavement. Okay, if the temperature is below standard temperature, then the correction applied is positive, and if the temperature is above the standard temperature, then the correction applied is negative. Okay, so what is the correction factor? It is 0.01 mm per degree centigrade variation from standard temperature. Okay, so assume if the temperature is 40 degrees at the moment and the standard is 35 degrees centigrade. So what is the difference? 5 degrees centigrade. Okay, and since the temperature is higher, then we need to apply a negative correction. So it would be minus of 5 into 0.001. This would be the correction that we need to apply. Okay, then analysis of data. So once you have obtained this value d, okay, then overlay design for a given section is based not on individual deflection value, but on statistical analysis of all measurements in this section. Okay, it is just not one deflection value. Okay, what we need to do is we need to find out, firstly we need to find out mean deflection, which is given by a formula x bar equal to summation x divided by n. This is the standard mean formula, as we already know. Then standard deviation we need to find out, sigma equal to root of summation of x minus x bar whole square divided by n minus 1, where n is nothing but the number of observations. Then once you have found out mean and standard deviation, then we can find out the characteristic deflection, okay, using a formula. What is it? ds equal to m plus 2s, where m is mean and s is standard deviation. This formula is used for NH and SH, national highway and state highways, and for other roads MDR, ODR and VR, DC is equal to m plus s. Okay, that is mean plus standard deviation. Okay, so this is it for BBD studies. I'll start with the next topic in my next class. Thank you.